Okay, so we have to start current electricity today, and we'll aim it to finish it by tomorrow, inshallah, because we just have to cruise through it. Uh, these are the topics that we have to do. I will share the recording and the PDF of this file with you if you want to make notes. Right now, don't make the notes, just try to understand it, because after this I'll be sharing the video with you, the recorded video, and then I'll be sharing the notes with you as well. Okay, so in the electric current, we'll be studying everything about the current. The new thing will be this I is equal to A N V Q, the drift speed equation. This is new. This is not in the IGCSE level. Then we'll study about potential difference in power. This is like the usual thing that you already know. Then we'll study about resistance and resistivity. So stuff about resistance and IV characteristic curves for filament lamp, for diode. And then we will explain how the filament ramp resistance changes, Ohm's law, then resistivity equation, R equal rho L by A. And then we will study about light dependent resistor. Okay, interestingly, in 2016 syllabus, they moved out this LDR and heat resist and thermistor like 0.7 and 8. They moved out in 2016 from AS and they shifted this into A2. But in this syllabus, right from this year, again, they moved back the LDR and thermistor from A2 back into AS. And one good thing is that one whole chapter of electric field has been removed from AS and it has been shifted into A2. So that's why this syllabus is shrink now, because one whole chapter is shifted to A2. Okay, and from A2 they have removed like 2 full chapters as well. So this time, actually, what they have done is in A-level physics, they have shrunk the syllabus by reducing 3 big chapters, and they just introduce 1 small chapter and 2 subtopics as well. Okay. So now let's start working on this chapter. First of all, you need to make these symbols. You have to be aware with these symbols. These are very like common symbols: connecting lead, cell, and then this is the battery, and then the fixed resistor, then the power supply, then junction of the conductors where some wires are connected together, and then the crossing conductors, like they are not connected with each other, but they are overpassing from each other. Then the lamp, voltmeter, ammeter, switch, then the variable resistor, this is the microphone, this is the loudspeaker, this is the fuse, the earth wire, and then the alternating current supply. Alternating current supply can be drawn like this. Okay, after this, this is the capacitor symbol, this is the thermistor symbol, LDR symbol, diode symbol, and light emitting diode symbol. So you just have to know these symbols. Okay. The next thing is charge. So first of all, we have to see what is charge. Charge is actually known as a bit of electricity. Like this is the fundamental thing in the electricity, the basic thing. Like in matter, the basic thing is atom, and in human body or in living organisms, the basic thing is the cells. So in the similar way, in electricity, the basic thing is charge. So positive charge are of 2 types, positive and negative. Like positive is on proton or nucleus, negative is on electron or negative ions. Then there is an equation for charge. Capital Q is N into small q, where N is the total number of charges and Q is the charge on one particle. This is like a simple thing. Okay, अगर हमारे पास 10 electrons हैं, तो उसके ऊपर total charge कितना होगा? तो N will be 10 and Q will be the charge on electron, which is 1.6 into 10 to the minus 19. So you just multiply them to get the total charge. Okay, this is important. What is elementary charge? Elementary charge is the smallest charge that can exist independently in nature. अच्छा बेटा, जो सबसे छोटा चार्ज जो इंडिपेंडेंटली एग्जिस्ट कर सकता है नेचर में, उसको हम एलिमेंट्री चार्ज कहते हैं, बेसिक चार्ज, राइट? और इस चार्ज की वैल्यू होती है प्लस माइनस 1.6 into 10 to the minus 19 कूलम, which is like the proton or electron charge, और इसको E से लिखा जाता है. Next is quantization of charge. So quantization means that the charge that can exist will be in the multiples of elementary charge. Like जो charge exist कर सकता है nature में, वो एलिमेंट्री चार्ज के मल्टीपल्स में हो सकता है, और ये उसकी एग्जांपल है. लेट्स से +-1 e हो सकता है, 2e, 3e, 4e हो सकता है. लाइक इट इज इन द मल्टीपल्स ऑफ एलिमेंट्री चार्ज. सो चार्ज कैन नॉट एग्जिस्ट इन फ्रैक्शन ऑफ एलिमेंट्री चार्ज. फ्रैक्शन में नहीं हो सकता, ये मल्टीपल्स में होगा. जिस तरह फॉर एग्जांपल अगर एक एटम है, सपोज ये एक एटम है और इसमें ये न्यूक्लियस है, राइट, और ये इसके शेल्स हैं और इसके अंदर इलेक्ट्रॉन्स हैं. लाइक पहले में 2 इलेक्ट्रॉन्स हैं और दूसरे में लेट्स से दूसरे में भी 2 हैं और इसमें 4 प्रोटॉन्स हैं. तो अभी ओवरऑल इस एटम के ऊपर चार्ज क्या होगा? तो बताएगा इस एटम के ऊपर चार्ज क्या होगा? एनीवन? इस एटम पे चार्ज क्या होगा? 0 होगा ना, क्योंकि इसमें 4 प्रोटॉन्स हैं और 4 इलेक्ट्रॉन्स हैं. तो +4e -4e, तो ये आपस में कैंसिल हो जाएगा, तो नेट चार्ज 0 है. लेकिन अगर आप कुछ करके एक इलेक्ट्रॉन निकाल दें यहाँ से, ये इलेक्ट्रॉन आप यहाँ से आप रिमूव कर दें, इस इलेक्ट्रॉन इज रिमूव्ड, तो अब जब इलेक्ट्रॉन निकल गया तो इस एटम के ऊपर चार्ज क्या आएगा? 4 प्रोटॉन -3 इलेक्ट्रॉन, तो 1 प्रोटॉन. इसका मतलब है इस पे चार्ज +1e होगा. अगर आप कुछ करके दूसरा इलेक्ट्रॉन भी निकाल दें, तो अब इसमें इलेक्ट्रॉन्स 2 रह गए, प्रोटॉन्स तो 4 ही हैं, तो 4 - 2 करेंगे तो इसके 2 प्रोटॉन्स, इसका मतलब है इसका चार्ज +2e होगा. अब इसका ऑपोजिट सोचिए. ऑपोजिट ये है कि ये 2 इलेक्ट्रॉन्स ऑलरेडी थे और आपने बाहर से इसको और इलेक्ट्रॉन्स दे दिए, 2 इलेक्ट्रॉन्स और दे दिए. अब बेटा जब आपने 2 इलेक्ट्रॉन्स और दे दिए तो अब बताएं इस पे चार्ज कितना होगा? तो चार्ज होगा 4 प्रोटॉन्स है -6 इलेक्ट्रॉन्स है, तो इसका मतलब है -2 इलेक्ट्रॉन्स, 2 इलेक्ट्रॉन ज्यादा हैं तो इसका चार्ज -2e होगा. तो -2, इस पे चार्ज नेगेटिव होगा. तो क्वांटाइजेशन ऑफ चार्ज का मतलब है बेटा कि जो चार्ज एग्जिस्ट कर सकता है या तो वो 0 होगा, या +-1e हो सकता है, +-2e हो सकता है, +-3e हो सकता है, +-4e हो सकता है. इट कैन नॉट बी इन फ्रैक्शंस, राइट? आई होप दिस इज क्लियर. Okay, then let's move to the next thing, which is current. So current is rate of flow of charged particles. This is like a simple definition, so we can just cruise through it quickly. And current, as charges are of 2 types, so current will be of 2 types as well. The first is conventional current. It is rate of flow of positive charges and it flows from positive terminal towards negative terminal. The second one is electric current. It is rate of flow of negative charges that flows from negative to positive terminal of the battery. Okay, so this is the thing. This is the conventional current that flows from positive to negative. So the red one in this diagram is actually the conventional current. The red one, like this is the positive terminal, like this is the positive terminal. So the current flowing from positive terminal towards negative. So these red arrows represents conventional current because they are flowing from positive terminal towards the negative. And then the other current is electric current. So that flows from negative terminal towards positive terminal. So that's all. We can say that conventional current flows from positive to negative and electric current flows from negative to positive. Okay. This is the liquid battery, and in the liquid battery you can see that the positive ions are moving towards the negative end, like towards the cathode, and the negative ions are moving towards the positive plate. The negative ions are moving towards the positive plate. So negative ions move towards positive plate, positive ions move towards negative plate. So the movement of positive ions is conventional current and movement of negative ions is electric current. So in a liquid battery, both type of ions are moving, positive and negative. But in a dry battery, dry cell, only one type of charges are moving. Okay, next is the current equation. You already know it is rate of flow of charges. So delta Q by T, its unit is ampere. It is a scalar quantity. So here are like some examples. That if in a wire 20 milliampere of current is maintained for 0.2 seconds, then you have to find how much total charge is moving through the wire. So we say that Q is IT, the current is 20 milliampere. You have to convert milli, like by replacing its value, 10 to the power minus 3, and the time is 0.2. So the total charge that is moving is 4 into 10 to the power minus 3 coulomb, or 4 millicoulomb. Okay, now we have to see how many number of charged particles are passing through the wire in 0.2 seconds. So for that, we'll be using Q equals NQ. So total charge आपने पहले निकाल लिया था 4 into 10 to the power minus 3, N आपने find करना है, and charge on single particle is known, which is 1.6 into 10 to the power minus 19. So you do the maths, and then you get the answer. Okay, so okay, it's actually the same question again. Okay, now let's move to the most important equation for this, which is I equals NAVE. Sometimes people say NAVE equation, NAVE, right? But this is the equation which was included in a syllabus back in 2016, right? And well, what are the terms in it? I is the current, I is the current, N is the charge density. It is charge density, number of charges per unit volume. Everything is explained over there as well. A is the cross-sectional area of the conductor, V is the drift speed of the charges, and E is the elementary charge value. So what we have to do is we have to look for an expression, like we have to derive this, I equals NAVE. And in order to derive it, we have to look for a term which is known as drift motion of charges in the wire. So let's say this is the conductor, and then in these things which are labeled with a circle and arrow, these are the charges which are moving in one direction, like forming the current. All of them are moving towards your right side. And the length of conductor is L, and its cross-sectional area is A. So charges move inside the conductor due to electric field set up by the battery. As there are too many atoms in the wire, so charges collide with them and lose energy in the form of heat, right? So let me just give you an overview of this thing to you. Let's say this is the conductor, and you have connected it to a battery. So let's say you have connected it to a battery which is having EMF E, and there are too many, of course, this is the metal conductor, so too many atoms are there to be a solid है, hollow तो है नहीं, इसके अंदर बहुत सारे atoms होंगे, right? और ये metal है तो ये atoms सारे regularly pattern में रहेंगे, lattice, इनको lattices कहते हैं, atomic lattices. Okay, now what we have done is कि जब इसको positive से लगाया तो इस conductor पे इस side पे positive होगा, और ये negative है तो इस side पे negative होगा. इस कंडक्टर के अंदर एक इलेक्ट्रिक फील्ड बनेगी जो पॉजिटिव से नेगेटिव की तरफ होगी. अब होगा ये कि जब यहाँ से चार्जेस मूव कर रहे होंगे तो वो जो चार्जेस हैं जब अंदर इंटर होंगे तो they will experience the collision with the atoms, and when they will hit the atom they will slide past the atom, and then they will move, hit the other atom, slide past, hit the other atom, slide past. So it means their motion is like along a zigzag type. So their motion will be known as the drag motion. So they are actually drifting motion भी इसको कह सकते हैं. Like जिस तरह normal pipe होता है ना, और उसके अंदर अगर water flow कर रहा हो तो water को तो कोई opposition नहीं होती, वो सीधा आराम से जा रहा होता है, वो किसी चीज को hit नहीं कर रहा होता. लेकिन unlike that situation, when the current is moving through the wire, so the charges, the electrons or the protons, they are experiencing multiple collision with the atoms. So due to this, they can't move straight, but they move like their motion is known as drift motion. वो drag करके आगे जा रहे होते हैं. Okay, so okay, now let's derive the main equation for it. Okay, hold on. So let's derive the equation. Okay, I have to highlight it again. That's why I have to erase it. Okay, now the first thing is like what we are doing. We are actually deriving this equation, I equals NAVE. How you have developed this equation, and this N is actually a small one. How we have derived this equation, this is the question, right? So we are working on it to derive this. So let's say the number of charges per unit volume of the conductor is known as charge density. This N, this small n is known as number of charges per unit volume. number of charges per unit volume, N by V. So small n is capital N by V. And this is charge density. And we know that current is charge over time. And we also know that charge is NQ. मतलब N number of charges or Q charge on one. Okay. अब हम ये करते हैं या charge की जगह हम E भी लिख सकते हैं. Q or E is the same thing. So what we do is we put this value of Q into it. So जब आप इसकी value put करेंगे तो see you got a new expression NE over T. Okay. Now you know that the charge density is N over V, and from there capital N is charge density into V. तो अब आप ये करेंगे कि अब आप इसकी वैल्यू वापस रिप्लेस करेंगे N की जगह. ये जो वैल्यू है ये आप N की जगह वापस रिप्लेस करेंगे. Okay, when you replace that, when you are done with that, तो कैपिटल N की जगह स्मॉल n और V लिख लिया. चार्ज डेंसिटी इनटू वॉल्यूम, ये E और T ऐसे आ गया. अब you know कि जो वॉल्यूम होता है वो एरिया इनटू लेंथ है. द वॉल्यूम इज एरिया इनटू लेंथ. ओके, सो ये जो बीच में वॉल्यूम है इसकी जगह हम एरिया इनटू लेंथ लिख देंगे. like इस वॉल्यूम की जगह सब्स्टिट्यूट कर देंगे एरिया इनटू लेंथ. So you can see I have substituted at place of volume area into length. अब last substitution, इसमें 4 substitutions है. तो the last one is, you know that L over T is speed. L over T. L over T क्या चीज़ है? I'm taking you back. L is the length of this conductor. So let's say the charges took time T to pass through this conductor, and as they are moving with constant speed, so we say that their speed is L over T, distance over time. So we will say, okay, what we can do is कि यहाँ पे ये जो L over T है इसकी जगह हम ये V लिख देते हैं. तो बेटा जब इसकी जगह V लिख देंगे तो you got the expression I equals NAVE, right? NAVE. So that is your final expression where I is the current in the wire in amps, where N is the number charge density, which is like per meter cube, and this is feature of material. Every material is having different value of N. Okay, जिस तरह कॉपर है तो कॉपर में चार्जेस इलेक्ट्रॉन्स बहुत ज्यादा होते हैं तो कॉपर की जो चार्ज डेंसिटी की वैल्यू है वो हाई होगी. इसी तरह आयरन के अंदर थोड़े चार्जेस कम होते हैं, वो कंडक्टर है लेकिन बैड कंडक्टर है इसलिए उसकी एन की वैल्यू लो होगी. तो जितना अच्छा कंडक्टर होगा उतनी उसकी एन की वैल्यू ज्यादा होगी. सो इट मींस दैट गुड कंडक्टर्स हैव हायर वैल्यू ऑफ एन and bad conductors have low value of N. That's the thing. Okay. Now, what is A? It is the cross-sectional area, जो meter square में होगा. What is B? It is the drift speed of the charges, meter per second में होगी. और E elementary charge है जो coulomb में होगा. Right? So this is the derivation. और इसके लिए हमने assume क्या किया था बेटा? वो मैं यहाँ बना देता हूँ. We assume a conductor of length L and cross-sectional area A, जिसके अंदर से चार्जेस जो है वो मूव कर रहे थे. ठीक है, ये चार्जेस इसके अंदर से मूव कर रहे हैं. तो हमने जो है वो पहला स्टेप जो किया वो ये वाला था हमारा, करंट इज चार्ज ओवर टाइम, और फिर हमने चार्ज की वैल्यू रिप्लेस की एन क्यू. सेकेंड स्टेप हमारा ये था कि जो हमने कैपिटल एन लिखा है उसकी वैल्यू हम रिप्लेस करेंगे एन वी से. और थर्ड स्टेप हमारा ये था कि जो वॉल्यूम था उसकी जगह ए इंटू एल हमने रिप्लेस किया. और फोर्थ स्टेप हमारा ये था कि हमने जो एल ओवर टी है, L is the length covered by the charges in time t, तो उसकी जगह हमने स्पीड को रिप्लेस किया. तो फाइनली we got this expression, right? अच्छा, if you have any question तो you can ask, right? if कोई doubt हो तो like just tell me about that. Okay, nothing. Okay, fine. So now what are the questions? The questions actually come from the drift speed. So what we do is we have to look for the factors of the drift speed in the conductors. कि आप drift speed को आप कैसे कम या ज्यादा कर सकते हैं. अच्छा, drift speed के लिए let me give you an example. मैं आपको एक example बताता हूँ. Okay, let me see if I can get the image. ओके, इमेज जो मैं आपको बेटा दिखाना चाह रहा हूं ना, वो है, आपने कभी अगर रबर का जो पाइप होता है, वाटर पाइप, अगर उसको पकड़ के आपने वाटरिंग की हो प्लांट्स को, तो उसमें एक तरीका तो ये होता है कि यू जस्ट होल्ड इट, और उसका जो एंड है उसको आप स्क्वीज नहीं करते, यू जस्ट होल्ड इट, तो आपको ऐसे लगता है कि बहुत ज्यादा पानी गिर रहा है, लेकिन वो ज्यादा दूर नहीं जाता और इसकी इतनी स्पीड नहीं होती। बट अगर आपने पानी थोड़ा सा दूर फेंकना हो, तो व्हाट यू विल डू इज यू विल स्क्वीज दैट, यू विल स्क्वीज दैट, आप उसके एंड को स्क्वीज करते हैं, और उससे क्या होता है, उससे ये होता है कि जो पानी की जो स्पीड है वो इंक्रीज हो जाती है। ठीक है, उसकी स्पीड इंक्रीज हो जाती है और वो ज्यादा दूर तक जाता है। जिस तरह सम टाइम कोई पाइप कहीं से अगर डैमेज हो जाए, वाटर पाइप, तो उसके साथ भी ऐसे ही होता है कि वो उसमें से जो वाटर है वो बहुत हाई स्पीड के साथ जो है वो बाहर निकलता है। अब इसकी मैं आपको एक इमेज दिखाता हूँ, ये देखें, ये वाला इमेज देखें, ये एक वाटर पाइप है जो कुछ जगहों से डैमेज हो गया है, मतलब ये यहाँ से देखो, यहाँ से देखो, और यहाँ से, इधर से डैमेज हो गया है, और यहाँ से भी डैमेज है। तो देखो वाटर यहाँ से बहुत हाई स्पीड से निकल रहा है, हाई प्रेशर और हाई स्पीड से निकल रहा है। ठीक है, लेकिन अगर इसी की जगह हम ये पूरा पाइप ही ओपन कर देते, तो वाटर ज्यादा अमाउंट में तो आता, लेकिन उसकी स्पीड कम होती, राइट। सो इसका मतलब ये है कि जो क्रॉस सेक्शनल एरिया होता है वो स्पीड को इफेक्ट करता है। लेट्स से अगर पानी यहाँ से आ रहा है तो उसकी स्पीड स्लो होगी, वी वुड बी स्लो। लेकिन अगर आप उसके एंड को स्क्वीज कर लेते हैं, अगर आप उसको पुश करके स्क्वीज कर लेते हैं, तो यहाँ से वाटर जो है वो बहुत ज्यादा स्पीड के साथ जो है वो निकलेगा। ऐसी है ना बेटा, faster, right? So when you squeeze the end of the pipe, तो उससे क्या होता है, पानी की स्पीड फास्ट हो जाती है। सेम कॉन्सेप्ट वी हैव टू अप्लाई ऑन ड्रिफ्ट स्पीड, कि हाउ द ड्रिफ्ट स्पीड ऑफ चार्जेस इन द कंडक्टर इज अफेक्टेड, in which situation charges will be moving faster in the conductor, and in which situation the charges will be moving slower. So for that what we have done is कि मैंने drift speed को subject बना लिया है, it is I over NAE. So drift speed is I over NAE. Okay, so now as you know I is NAVE. So from here मैंने drift speed को subject बनाया, so it is I over NAE. ये आपके पास आ गया। अच्छा, अब बेटा इसके फोर मतलब V depends upon four things. Number one is current, number two is N, number three is area, and number four is E. So let's look at them one by one. सबसे पहले drift speed is proportional to current if you keep all other factors constant. So अगर जिस कंडक्टर में करंट ज्यादा होगा उसमें ड्रिफ्ट स्पीड भी ज्यादा होगी according to the relation. Second is N, and drift speed is inversely proportional to N. इसका मतलब है जिस कंडक्टर में N हाई होगा, मतलब N की वैल्यू लार्ज होगी, मतलब उसमें चार्जेस ज्यादा होंगे, उसमें ड्रिफ्ट स्पीड स्लो होगी। और जिसके अंदर N की वैल्यू कम है, उसमें अगर करंट सेम है लेकिन N की वैल्यू कम है, तो इट मींस कि ड्रिफ्ट स्पीड शुड बी फास्टर देन। Okay, the last expression is कि drift speed is inversely proportional to area. So keeping N and I constant. Okay, N क्या चीज है, चार्ज डेंसिटी, it depends upon material. Material अगर कॉपर है तो सेम कॉपर है, चाहे वो थिन वायर है चाहे थिक वायर है, उसकी N की वैल्यू सेम रहेगी, राइट। ओके, सो अगर बेटा आप क्रॉस सेक्शनल एरिया चेंज करते हैं, लेट्स से आप क्रॉस सेक्शनल एरिया इंक्रीज करते हैं, तो ड्रिफ्ट स्पीड डिक्रीज हो जाएगी। अच्छा, क्रॉस सेक्शनल एरिया की जगह रेडियस और डायमीटर भी हो सकता है, क्योंकि यू नो एरिया इज पाई आर स्क्वायर और एरिया इज पाई डी स्क्वायर बाय 4, सो दैट्स व्हाई एट प्लेस ऑफ एरिया यहाँ पे रेडियस और डायमीटर जो है वो भी हो सकता है। ओके, okay, so let's move to the next thing. Okay, so let's do this example. Okay, let's say beta this is a copper conductor. यहाँ पे इसका क्रॉस सेक्शनल एरिया ज्यादा है, वाइडर है, और उसके बाद जब यही कॉपर कंडक्टर हम आगे लेके गए तो वहां उसका एरिया कम हो गया, राइट? बट दीज आर इन सीरीज, और एक बैटरी ईएमएफ ई के साथ उसको कनेक्टेड है, और लेट्स से यहाँ से इसका एरिया 3a है और यहाँ से इसका एरिया a है। तो जो ब्लू वाला है उसका एरिया 3a और जो आगे येलो वाला है उसका एरिया a। अब चूंकि ये दोनों सीरीज में लगे हुए हैं और ये जो कि दोनों कॉपर हैं, कॉपर एंड कॉपर, तो इसका मतलब है उनके एन की वैल्यू सेम होगी, बिकॉज एन डिपेंड्स अपॉन मटेरियल। फिर आई भी सेम होगा क्योंकि बोथ आर कनेक्टेड इन सीरीज। अब हमने ये देखना है कि किस में ड्रिफ्ट स्पीड ज्यादा होगी और कितनी होगी। तो चूंकि एरिया ऑफ वाई, सिलेंडर वाई इज लेस देन एरिया ऑफ एक्स, इसलिए अकॉर्डिंग टू द ड्रिफ्ट स्पीड एक्सप्रेशन जो हमने पीछे यूज किया था कि ड्रिफ्ट स्पीड इज इनवर्सली प्रोपोर्शनल टू एरिया, तो जिसका एरिया कम होगा उसके अंदर ड्रिफ्ट स्पीड फास्टर होगी। इसका मतलब है y के अंदर जो ड्रिफ्ट स्पीड है, क्योंकि उसका एरिया 3 टाइम्स कम है x से, इसलिए इसकी जो ड्रिफ्ट स्पीड है वो 3v होगी, और इधर इसकी जो स्पीड है वो सिंपल v होगी, राइट? So the drift speed of charges in conductor y is 3 times more than drift speed of charges in conductor x. Okay, now we have to move to next thing, which is terms used in electrical circuits. These are the simple terms, so we can cruise through this. Electrical circuit is a combination of cell, battery, connecting wires, resistors, and measuring meters. As sources of energy in the circuit is always cell or battery, which supply energy, and sources which are using energy are actually resistors, load, or wires, etc. Actually, they consume electrical energy. So what is EMF? We just have to look for the definition. It is electromotive force. It is the work done per unit positive charge by a source to move it around complete circuit, right? So that is known as EMF of the source. So work done per unit positive charge by a source in order to move it around the complete circuit is known as EMF. So EMF is work done per unit charge, and its unit is volt, which is joule per coulomb. Okay, there is another definition as well. It is amount of energy converted from non-electrical form to electrical form when unit positive charge moves through a voltage source. So when, let's say, let me explain this. If this is a cell connected in a circuit, and let's say 1 coulomb of positive charge is passing through it, and then what the cell will be doing is, cell will be shifting its chemical energy, giving its chemical energy to the 1 coulomb charge. And when this 1 coulomb charge will be coming out, it will be having some energy with it, right? So we say that the EMF is actually the amount of chemical energy that cell has provided to unit positive charge when it is passing through the cell. Okay, so about its equation, EMF is energy over charge, EMF is energy over charge, and its unit is again volt. Now, what is potential difference? Potential difference is same as EMF, but in opposite way. Work done per unit positive charge to move between any 2 points in the circuit is known as potential difference. Or we can say that amount of electrical energy converted into non-electrical energy when unit positive charge moves between 2 points in the circuit. Like the definition is similar to EMF, and its formula is same. Potential difference is work done per unit charge, or potential difference is energy per unit charge. And again, its SI unit is volt, which is same as EMF. So EMF and potential difference both have same equation and same units. The only difference is of energy conversion. In EMF, energy is converted from non-electrical to electrical, and in potential difference, energy is converted from electrical to non-electrical. Okay, so here is a description for the EMF and the potential difference. So maybe I have to draw it again for you. So let me quickly draw it again. I am just going to give you an idea about EMF and potential difference. So let's say, beta, this is the wire. I am going to make a wire in the form of a pipe. And then let's say there is a resistor over here. This is the resistor. The wires are connected to the resistor. Okay, now this cell is, let's say, having an EMF of 12 volt. It means that it will give 12 joule of energy to every 1 coulomb charge that will pass through it. Since you know that, you know the formula for EMF. So EMF is energy over charge. So if it is 12 volt, it means 12 joule of energy will be given to every 1 coulomb charge passing through the cell. Okay, so when the charge is, okay, so let's say these are the charges which are coming out of the cell. So these are the positive charges and these are full of energy. Okay, what's the energy of these charges? These charges have energy of 12 joule per coulomb and 12 joule per coulomb because these wires are ideal. So these are ideal wires. These don't have any resistance. Okay, when these charges are moving through the resistor, what's happening is they are losing their energy. They are losing their energy. And when they will come out of the cell, whole of their energy is gone. But still they will be moving towards the negative terminal of the battery because they are positive charges and negative terminal attracts them. So what happens in the resistor is that their energy, the energy of the charges or the electrical energy is dissipated in the form of heat. So when they leave, when charges leave the resistor, they don't have any energy. But as these are positive charges and this is the negative terminal of battery, so the negative terminal is going to attract them. And when these empty charges are going through the cell, the battery again refills them. The battery again refills them. So when they come out, they are again full of energy. So the role of battery is to refill the charges with the energy and send them to the circuit. And the role of resistor is to consume the electrical energy of the charges and convert it into other forms. That's how electrical devices work. Okay, the last thing is this electrical power. Electrical power. Okay, so the input or output power associated with electrical devices or circuit is known as electrical power. And we know that P equals IV. That's a common equation. We have to derive it. You know, power is work over time. And we also know that potential difference is work over charge. So from here, work is potential into charge, VQ. Then what you do is you put this value over there, like the value of VQ, put it over there. So when you put this value over there, you will get power is VQ over time. And then again, you can look that what is this Q over T? So Q over T is equal to I. So that's how we can say that power is VI, where V is the potential difference and I is the current. Okay, now power P is IV. So IV is used to find the power produced by battery or voltage source. Remember this thing, this is very important. That if you want to find how much power is produced by the battery or cell, you have to use IV only. So at place of V, we can write E, which is the EMF of the source, and I is the current in the circuit. The next thing is power dissipated by a resistor. So when current flows through the resistor, it dissipates the energy and that is known as power dissipation. So हम P equals IV भी use कर सकते हैं, whereas the current through the resistor and V is potential difference across the resistor. And we can use some more things as well using Ohm's law, V equals IR. So you know power is IV and Ohm's law V equals IR. So you simply have to substitute its value, that value of V, substitute it over there. So you will get IR, मतलब V की जगह IR लगा दिया तो I square हो गया. So you got this P equal I square R. So this is the new expression. And then similarly at place of I you can put V by R because I is V by R. इसमें I की जगह V by R लगा दो तो V square over R square, फिर R से कट जाएगा तो you get V square over R. So another expression for power is V square by R. Okay, let me summarize it. Power is IV, power is I square R, power is V square by R. So any of the above expression can be used to find power dissipated in the circuit. To find power produced by voltage source, only P is equal to IV is used. So for power dissipation, any one of the three equations can be used. But for power production, you will be only using P equals IV. And then is the electrical energy. You know power is energy over time. Energy is power into time. And at place of power, you can write IV, you can write I square R, and you can write V square by R. So that's how you can find electrical energy. Okay, so only 3 people left. Well, it's really strange in the online class. Initially, it was 6 people, and now only 3 left. So 3 are gone. And I think that most of you think that this is an easy topic. Let's say Aisha was telling me, a student from A2 who is retaking AS as well, that sir, electricity is so simple. Why you are teaching this? So I said, beta, अगर electricity इतना simple होता तो आप दोबारा repeat न कर रही होती, right? So the thing is, most of the students think कि अच्छा भाई ये तो इतना easy topic है, तो just leave it. Just leave it. They don't focus on it, and then they lose marks in the easy stuff. So my advice to 3 of you is that don't take anything as an easier version. Don't take anything कि भाई आपको आता है ये तो बड़ा आसान है इसको तो छोड़ दो. You have to be good in the easy stuff. क्योंकि challenging तो शायद आपसे हो ही ना या किसी से हो ही ना, तो easy वाले में तो कोई mistake नहीं होनी चाहिए ना. So when you will focus more on the easy stuff, only then you can do better in that, right? So this was the thing till today. I guess it's enough. Yeah, because the second topic is this Ohm's law, and then we have to go through Ohm's law and IV characteristic curves. We'll study this tomorrow. And then like the graphs, these are the all graphs that we will do. Then we will study thermistor, then we will study LDR, and then we will do some resistivity questions, right? And then tomorrow after this, we will be solving these questions as well, right? So that's it for today. The class time is over as well. So what I'm going to do is I'm going to share these slides with you, not slides, but